of the two numbers such that they add up to the specific target. You may assume that each input would have only one solution and you may not use the same element twice. So I did us a favor, here's our function signature. How are we gonna approach this guy? And let's start with what would be the brute force solution. Do, 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 do. What would be a really easy way to find two numbers in an array? Everyone doesn't have to speak at once.
You could use two for loops to compare every number to each other.
Cool. Use two for loops to compare every number. So that would be something like for I in nums, and then for j in nums. Well, what would be the problem with doing it this way?
Time complexity?
Yeah, so this is going to have time complexity of O of n squared. But also, this way of setting up for loops can't work at all, and it'll inform a better solution for a specific reason. Why won't this work at all? What are we trying to return from this function?
The indices?
Yeah, we can't do this. We need the indices of those numbers, the nums. Okay. So we would get the indices in these for loops in the same way we would if we just used a single for loop. And I'm going to recommend we go with that solution. How do we get, or how do we at least count the indices of numbers in a for loop? How can we get access to that?
I use for loop.
Yep. So we enumerate, we can do for, and then the first value in this tuple is an index. The second is the actual value in that space in nums.enumerated. Reminder that enumerated starts counting from 0. It's not actually referring to the indices, but close enough right now. Okay, that's important for other times when we're using indexes, but this is going to be great. We can use a for loop to get both the indices and a value at a specific time in nums. So the first loop through this array we have here, we would have the tuple 0, 2, and then 1, 7, then 2, 11, and then 3, 15. Well, here's a question. What do we want to actually do? How do we get an answer? How do we know when we have our answer?
Well, when you're iterating through the array, each time you could subtract target minus whatever iteration we're on and add it to a dictionary where the key is the remainder, and the value is the indices.
Okay, so can you walk us through if we were using this array? How would you set it up for this array?
Like, are you asking for encode or just walk
Just
through?
talk me through what would happen with each value.
So you're at your first iteration, you're at 2. You would first want to check if 2 is in the dictionary that you've made. And it isn't because it's the first one. So what you would do is do target target minus that number in that iteration, and add that to the dictionary. So like dict, square braces, target minus value equals index.
Dict, target minus value. Okay, so this dictionary, let's just make sure we all understand it. For anyone who's using this dictionary, what are the keys in the dictionary?
The keys are the whatever value you get after doing the operation of target minus value. So the target minus whatever number we are on in that iteration.
Okay, I'll just call it number we got from math.
Yeah.
And then the value for it is actually the index in the original array.
Yeah.
Something like that. So if we set up a dictionary in this way, we can get actually a pretty simple solution, because adding it to a dictionary, let's see. Jocelyn, when I go to look something up in a dictionary, or I go to add a value for a key in a dictionary, what is the time complexity?
Say that one more time.
Yeah, if I go to either look up a key, so get the value for a key, or if I go to set the value for a key in a dictionary, what is the time complexity of look up or write to a dictionary?
I'm not sure.
Okay, give it a guess. Give it your best guess.
Say O-N.
Okay, so O of n would mean it has to look through every element. I'm gonna throw it out there. Why would we use a dictionary? What makes this special or easy to use?
You're asking me?
You can throw it to anyone else if you'd like to, though.
How about Carrie?
Carrie. Hey, Carrie.
How about Carrie? How about Rod?
Okay. Did we lose Carrie? Carrie, where'd she go?
Yeah.
Hi, Carrie. Nope, no Carrie. Hi, Rod.
Hi, and I'm Rod.
Hi, Rod.
What is the time complexity of looking up a dictionary? It's O of n, I believe. No, O of
So,
1. Sorry. It's
there you
constant
go.
time. It's constant time.
Yes, it's going to be constant time, any lookup in a dictionary. And that's why we love dictionaries for these kinds of things, is it's really quick to get access or to just overwrite the value for a key. So I'm going to suggest something a tiny bit different, just so that our dictionary is, let's say, a little more pristine. So I'm going to say in each iteration of the loop, we'll see if we will, another approach, which is only slightly different. We will find the difference between target and the value we're looking at. Then we will look in the dictionary to see if that value exists. And if it does, the value we get from looking it up provides us with the index for this, we can call it a complement. So with this loop we were in before, 2 does not have, so our target is 9. That means the complement is 9 minus 2, which is equal to 7. That's not in dictionary. So we will add dictionary at 2 is equal to 0. So we'll add the value at our current iteration as the key, and we'll add the index at our current iteration as the value. Because what we can do in the next iteration is we can just kind of blindly say, all right, what is the complement between 9 and 7? So 9 and 7 is 2. Dict at 2 exists, and it's the value for that key is 0. And we can return an array with dict at 2, comma, and the index at going all the way back, the current iteration of our loop for our enumerated nums. So the one reason I would recommend this is just that we're not saving any math, we're just looking up things that we've seen before. So rather than in the dictionary storing the result we found, if we just say, here's a log of everything I've seen and its index. So for the first loop, I said, go ahead and look this up. Well, it's not there. So let's just store that the value 2 was at index 0. I'd recommend this because you do see this in a lot of problems. So this approach with a dict to make a memo or a past-facing guide is pretty common in interview questions. And that's the only reason I would say to do this is think of this like inputs and outputs, or think of it just as like, you know, the key value pairs that you see, or a tuple. So for every iteration of an enumerated array, I can keep track of the value that was in a space and its index. I could also do this in other cases in reverse. I could keep track of the keys as the indices and the values that they hold in this dictionary. And the nice thing is I can then always backtrack. I can quote unquote backtrack in the array at each index of the iteration by using this dictionary. So in terms of the keys and values here, what this dictionary would hold is, as the key, it would be the value in original array, and the the value for the dictionary would be its index. And then at each place, we just say, well, the missing part of the addition, see if that value we're looking up is a key in the dictionary. And if it is, then we can return what's returned by looking it up in the dictionary and the index of whatever we're looking at. So this is kind of like being able to look at everything we've seen in previous iterations without having to run 2 for loops. How do we feel about this thus far? What are some questions? Okay. Let me ask a question here. So they helped us out in this problem. They said all the numbers in the array are different. When would this approach with a dictionary not work? If you're in the chat, sorry, I'm just trying to keep it on mic. Can you come on mic? I think that was Eric.
Negative numbers?
So negative numbers will work because they can just be keys. If this array here is int to int, then you can just have a negative number as the key. It's still hashable. But this wouldn't be the right data structure to use. We wouldn't be using a dictionary if the array has duplicate values, because then we wouldn't have a unique entry for each of them. That's where we would consider some other thing. They told us in this problem that the array will only have different numbers. There will be no duplicates. So we can say, okay, well, I know definitely that the only 2 is at index 0. And so I can save a key value pair. But if the array had duplicate values, then I could not use, or a dictionary wouldn't be the right tool to use here, because if there was a 2 here, then if I made it through the whole thing and I went to write dictionary at 2, I would lose this index here. I would overwrite dictionary for the key 2 as having the value 4, this new index. Okay. All right, let's code it. So we said we were going to have a dictionary. We're going to loop through enumerated array. We're going to calculate the complement, and we'll return if we find the complement as a key in the dict. What about if we don't find it? What should we do?
Return an empty array.
Yeah, sorry, so staying inside of this loop, still inside of the loop. If it happens that we don't find the complement in the dictionary, what should we do?
Add it to the dictionary.
Yep. Add the current value and its index to the dict. And this is kind of hacky, but they told us we should expect to get an answer, but to make Swift agree with us at the end, we'll just return an empty array. If we don't find it, just to make Swift okay with what we're doing. Cool. So Eric W., can you start us out? Let's make a dictionary.
We can create a variable.
Mhm.
We can call it dict, D-I-C-T,
Love it.
and that's equal to open square bracket, and it consists of the value. The key is int, and the value is also int.
Sweet.
We need to initialize it.
Awesome. Looks great. All right. And can you start our loop for us, and then we'll pass it off to Nima?
Let's say for I in from 0 dot less than nums dot count, and you open a curly bracket.
Cool. So this will work because we have access to all the indices from the beginning of the array until the very last index of the array. But let's say I want to do something a little more Swifty. This is perfectly valid, but I want to come up with a Swifty solution. Can use the indexes by looking through a range and looking at nums for I. Let's make an enumerated array though. So Nima, let's loop through an enumerated array.
Okay.
Our array is nums. How do we
Wait,
set up
where
that for loop?
Okay. So we're not doing, okay.
Yep.
For, so I guess for I in nums dot enumerated.
Cool.
Okay.
Let's see what I is. I is this weird looking thing. How can we make this easier for ourselves?
For num, can you do for num? Does that make a difference?
We could do num, but what we get with an enumerated array is we actually get a tuple that starts at 0 and the value at the first index. And then the next iteration, we get 1 and the value at the next index.
Oh, okay. So the way we set it up was for index and then parentheses num in nums dot enumerated.
Okay. Let's do it like this. So we just have a tuple that we can use.
But like yeah, in parentheses.
Yeah.
Sweet.
Okay.
Sweet. So
Do
we
you want
loop
me to
through.
keep?
Yeah, keep going.
No.
Now let's calculate the complement.
Okay. Did we define what that is?
So the complement is going to be
If this is different.
the number that we add to num to get target. And how can we do math to get that?
Okay, so target minus num.
Cool.
Okay, so that's our complement.
That's a complement.
Return if we find the complement. Oh, so we have to make sure there's something there first?
Yeah.
Is that
How
what
can
this said?
we like look in a dictionary to see if we got a thing?
So if dict num, do we want to put num in there? Or
So
index, or of the complement?
yeah, let's go see if we find the complement.
Is not equal to nil.
Okay.
Then return so we're doing so okay, because sure, so just return complement, like array of complement.
So yeah, this is where like we kind of have to turn it on its head. The key is complement, but we want the value for complement because that's going to be the index that we later store.
So return complement dot value. Can we do that?
So complement's just an int here, but the value in the dictionary at complement we can just get by looking in the dict like that, right?
Ooh, okay.
And then we also want to, the annoying thing here is our return will always be an array with 2 indices in it.
Mm-hmm.
The first one is complement. What's the second one going to be?
Num.
So num is the value, but we want an index. We want to know the index of that value.
So dict num.
We don't quite know that that exists, but we do have some other information from our loop here.
Okay, we could pass it on.
Yes,
Like, okay.
thank you. Those heroic effort. Let's pass it to, do you want to pass it to me?
Yes, I would like
Okay,
to.
I'm going to pass it to me. Okay, so if we want to return here, what we're returning is the index stored in the dictionary and the index of the number we're looking at currently. How do I get the index of the number stored in the dictionary? Well, that's this guy right here. We're going to get this error because it's optional, because we want to look up a value in a dictionary. We'll deal with that in just a sec. But the index of the number we're looking for currently is just going to be the first value in the enumerated tuple for this. So it'll just be that index that we set up. But this is still optional. We've got 2 choices. We could either use a bang to force unwrap it, or what's the other thing we can do, Eric W?
To force unwrap it.
I don't want to
Like
do that though. What's the other thing we can do with
Oh.
optionals? A little safer.
You're giving like a value on it, like the one with forgot the term.
What's it look like?
And
It's
I
okay.
don't know, David. Sorry.
That's okay. So it's actually like at this line 59, we're doing something that we often do in a different way. We're checking for nil here, but what we often do is we use optional binding to get a safely unwrapped value there. So instead of just checking for nil, we use binding as a way of both checking for nil and then having that value as an unwrapped optional. And so this is just an int because we used optional binding, and we can just return that there. That's nice, that's safe. That makes us all happy. And so if we do find the complement, so if we find the number that when we add it to num, we get target, or kind of in reverse, we find the number that target minus num equals as a key in the dictionary, then we return the index of the original array that it occurred at. And that's what this complement index is. So if we use our math and we look up what the complement would be, what we've done, or what we hope to do, is save the index it occurred in the original nums array, that when we look it up, we can just return that and the index of what we're looking at. But to get this to actually work, we have to, if we don't return, so at this next step, we have to add the value and its index to the dictionary. So if we don't find that number, that's what this is doing. It's saying, hey, whatever number adds up with num to get target, if we don't find that, this whole block gets skipped. So then here, what we want to do for the next step, for the next iteration, is add that number to the dictionary in a specific way. Eric M., I'm going to ask you to take us home here.
Where's home?
I just want to be able to add those values to the dictionary, and then we've actually completed the entire thing.
You want to add the complement to the dictionary?
So I don't want to add the complement. I want to say, if we don't find the complement, so if we don't find the number that adds to num, I want to add the current value, so num, and its index to the dictionary.
So your dictionary bracket I don't find the complement. Complement index, right?
So we don't have that because our optional binding failed. We're outside the scope of that. Let me do one of these. Nope.
Oh, the bracket num equals parentheses dictionary bracket num default value. I mean, if you don't find. Oh, equals, never mind, scrap that.
Okay,
Equals index.
sweet. Can you tell me why you did that? What does our dictionary store?
It's creating the key for num and it's storing the value index.
values are the indexes those numbers occurred at. And so what we kind of did is we turned an array inside out using a dictionary. Its values, because they're all unique, are stored as the keys in the dictionary. So this is weird because it's kind of like turning an array inside out. Normally we would use a subscript, so these square brackets, to look up indices of an array. But here we are turning it around so that we can just do math at line 55 and say, hey, if you find that value, so if you find that number that existed at a different spot, then I know that number adds up with the number at my current index. And then those are the indices. The indices of those two things are the value we get from the dictionary and the index we get from enumeration. Those indices are where I can find in the original nums array the two numbers that add up to my target. This one is it's kind of wild. I love it. So what we did was we took an array, we inverted its values and its indices to make a dictionary that's kind of the inside out array. And we used that dictionary to be able to say what indices we were looking at in the original array. That is kind of the trick of two-sum. What are some questions?
And harder to keep track of.
Yeah, I mean, logically, they're kind of the same thing, right? You're just saying like, if basically, if you need this number as your complement, its index is this.
Yeah.
It's the flip side of doing what we did. I think this is just more straightforward in terms of saying like, this value was at this index in the original array. But they are logically equivalent.
Gotcha.
Cool.